So section 10.8, we are going to talk about the power theorems. These are going to be three theorems that we're going to look at. They're basically three formulas looking at the relationship in the segments that you get with chords and secants and tangents. So they're going to seem very familiar. We had the same situation with the angle-arc relationships and those formulas, but now we're going to be dealing with the segments. So the first one we're going to talk about is the chord-chord power theorem. And remember, we had a diagram like this where we had two chords intersecting each other, but before we were talking about figuring out the measure of this angle based off of the two arcs that were created. Well, now with the power theorems, what we're going to be doing is looking at the lengths of these four segments that are created and coming up with a formula or relationship between those four segments so that you could maybe perhaps solve for one of the missing segments. So in the chord-chord power theorem, we are looking at taking this segment AE and then multiplying it with EC, and that's going to equal segment BE, this little piece, multiplied to segment ED. So it's basically taking the two little parts of one chord, multiplying them together, and then the two little parts of the other chord and multiplying them together, and they should equal the same thing. So that's your chord-chord power theorem. The next one, theorem 96, this is your tangent-secant power theorem. And so remember, you're going to have this piece that is tangent. That means that it only touches the circle at exactly one point, even if you were to continue it on. Okay? And then this right here is the secant, which it will eventually intersect the circle in 2 points. Okay? So the formula or the theorem states that if you take the tangent segment CB and you were to square it, it is equal to the little piece that's outside of the segment, or the secant segment, this little piece, dB, multiplied to the entire secant. And that's going to be hard to remember because a lot of people take dB and multiply to dA, kind of like what you did with the chord. So just remember that you're going to take this part and multiply it to the entire secant, okay? And then it's this piece squared is equal to that times the whole thing. Okay, this hopefully should seem kind of familiar. This kind of is reminiscent of your altitude on hypotenuse theorem, right? If we had drawn in CA and drawn in the altitude down to AB, then this would be like the altitude on hypotenuse theorem. Okay, the last one is the secant power theorem. So now we have two secant segments, and you notice that we have two parts that are outside of the circle, these two little segments down here. We have chords, right? But we also have the entire secants, AB and CB. So the secant power theorem says that you're going to take dB, this little piece that's outside of the circle, and you're going to multiply it to the entire secant, and that will equal to this other little piece that's outside of the circle multiplied to the entire secant. Okay, so little piece times the whole thing equals little piece times the whole thing. So just be careful not to do this little piece times the chord equal to this little piece times the chord. That would not be correct. All right, so I think we are ready to take a look at some examples, which are on the next slide. Okay, so the first example we have is for the chord-chord power theorem, and it looks like they're asking us to find EC. And they've given us EB is 5, ED is 9, and AE is 3. So using your chord-chord power theorem, we're going to take this segment and multiply it by 3, and that will equal to that segment 5 multiplied to this segment of 9. So there's our equation, 3x equals 9 times 5, and when you go to solve it, you get x equals 15. All right, so let's take a look at an example for the tangent-secant power theorem. So here they're asking us to actually find this length of the tangent segment. And they've given us the little piece, dB is 4, and they've given us that the chord itself is 12. So the first thing that we're going to need to do is actually add this together because we need this entire length. And so 12 plus 4, we get 16. Okay. So when we go to apply our tangent secant power theorem, we're going to take y and square it, and that's going to equal the 4 multiplied to the whole thing of 16. So we get y equals 8. All right, next one, last example. This one's for the secant. This time, they're actually asking us to figure out the length of this chord, AD. And they've given us these 3 other parts. So the 3 is fine where it is. We can add these together when it comes time to the formula. Over here we have 10 and 5, so let's go ahead and just add those together so we remind ourselves to do that. Ooh, that was weird. Okay, yes, I can draw 5. Good. Okay, so when we go to use our formula, we're going to take 3 and we multiply it to this whole thing, which is 3 plus w. Don't just do 3 times w, right? And then this side, we take 5 and multiply it to 15. So when we distribute our 3 and simplify, we end up getting w is 22. Okay, so we just have 3 formulas that you guys have to remember for this section, and just don't get them confused with your angle arc formulas that you had, right? All right, see you later.